So start off with what we're going to cover. I'll do a quick introduction. We're going to talk a little bit about sampling, so why you should sample, and then some tips on how you should sample to get a good sample. That way when you send it in, you're not getting answers on something that you don't really need to know about. Talking about the analysis and what we can do, and then understanding that analysis. When you get the results, what does it mean? Taking action or taking the appropriate action. Sometimes you don't want to overreact to something, and sometimes if something is bad enough, you do want to quickly react to that problem. And then at the end, we'll talk a little bit of a case study of a wire drawing company that I have on here. So we'll start with sampling, why you should take a sample. So biggest thing is to protect your assets. So if you have an important piece of equipment that is making your product or whatever to make you your money, it's going to be important to keep that to run. As has been mentioned before today, if there's downtime that's unplanned, that's not a good thing. That means that somebody up above is frustrated, there's money that's not being made, and kind of we don't know what to do. By sampling often, or not even too often, but just sampling your important components, you can keep and monitor those levels, and then you can make decisions on that component, and then you can plan ahead for an outage if you need some kind of maintenance or something like that, and then that way you're not having anything unplanned happening. Nobody likes that. And then also, sampling can help improve the quality of your product. We'll talk a little bit about that in our case study, but just kind of fully understanding the process and controlling everything about the process, and you're going to get that from sampling to get that information. Also, sampling can help you catch little things like wrong or mixed lubricants. Sometimes, guys walking around with his grease gun and he's pumping grease in, he sees something with red grease, so he just starts putting his red grease in there. Two different products, they just have the same color, so he just started putting it in. So we can detect that through the analysis with oil and grease of seeing if somebody put the wrong product in there and say, well, this is why you're having an issue. Somebody put the wrong lubricant in there. So there's lots of little things like that, or contamination. If you've got a lot of moisture coming in from your environment or dust or anything like that, depending on your specific applications, trying to minimize that contamination. Obviously, if your lubricant gets contaminated, it's not going to perform well, and then you're going to have issues either with your product or the machinery itself. Moving into the next thing of how to take a good sample. In that picture there, you see the bottle. This is a special bottle that has a vacuum seal, so when the bottles are made in the warehouse, they'll put a vacuum line on it, put it under pressure, and then they will turn that white knob that you see the guy's hand on, and they'll lock that vacuum pressure in. And then that way, then you have the white tube on the nipple of the bottle right there. He sticks that down inside the machine. He then opens that vacuum. The vacuum is going to suck the oil sample out of the machine. It's set at a certain pressure, so it's always going to take the correct amount of volume, leaving headspace in the bottle. Kind of takes out any kind of headache of taking a sample for you, makes it consistent, and then also guarantees it that all you have to do then is twist your white handle, lock the bottle, and then the bottle's never been opened. So you don't have to worry about all your dust or anything from the environment dropping in and contaminating your sample. You've got an actual snapshot of the lubricant, as was in the machine, pulled out and sent to the lab for analysis. You don't, set it down and they wipe the top with their shop rag or something like that and put all this stuff in the sample. That will ruin your sample, have you chasing something that's not actually there. And more about how. This is also another setup, so that can be retrofitted onto a machine, and then you would come along and then you would hook up a tube and a bottle, and then you just unthread that. Oil would be able to start flowing out. You take your sample, close it again. So the same idea too is you're also minimizing risk for your equipment because you're not opening up your equipment. You're not opening the chance of the dust to also get in your equipment, hurt your equipment, vice versa, hurting the sample. When you take a sample, like I said, you want the sampling report or sampling port because it allows repeatability and reliability in your sample. Doesn't matter if you send out anybody on your maintenance crew to take the sample, they're all just hooking up to the sampling port. So it's really easy that it doesn't matter if Steve, Jim, or Bob goes out, they're all going to get the exact same sample because they're going to the sample port, and it's not having to say, well, Steve has this technique where he fishes the line down in with this. You don't have to worry about anybody doing anything special. It makes it easier. That consistency allows you that when you do take a sample to then trend your sample over time. So ideally when you're taking samples quarterly or biannually or even annually, depending on the equipment, you have that trend. So you can see, 6 months ago or 4 months ago, our oil looked pretty same we've only lost a little bit. You can kind of just know what's happening, take action, and that's going to cue maintenance or anything like that might need to happen. Also, important thing, like I said, with the vacuum bottle is the sampling size. So when it comes to the lab, there's you want some headspace in the bottle, reason being that we can then agitate the sample. So if the sample is actually too full, we can't shake it properly, and then we can't ensure that the sample is homogeneous. So then when we're analyzing it, we might be giving cues, and it's just that aliquot that we pulled out is bad, but the whole thing might not have been, and kind of hurts the analysis. So things like that, we want to work with the customer to make sure that they're going through the effort to get a sample. We want to make sure that they're getting value out of that analysis, that they're not just spending money to get analysis. Another thing too important for sampling is labeling correctly. You wouldn't believe how many times we have customers send us in something and they switch them and they put the label on the wrong thing, and we can just tell by looking at it based off of the trend, but we have to go back to them and say, did you sample, is it possible that switch the labels up or anything like that? And then also it helps because if you switch two pieces of equipment and the one has a reservoir that's 4 gallons and the other one has a reservoir that's 400 gallons, and we say, oh, you need to do an oil change, a 4-gallon oil change and a 400 oil gallons are a little bit different in cost. So it's important too that you want to make sure that when you're taking action on the equipment that you're supposed to. So in the lab, we have tons of different analytical tests that we're running. I won't get into a bunch of them, but if anybody has questions, you can ask me later about specific tests if you have any questions about them. But a lab really should be looking at wear data, contamination data in a sample, and then physical properties. And then also with grease, you have consistency. Your physical properties for your oil would be the viscosity of your oil, antioxidants that are in your oil. Those are an important thing. A lot of people will trend those, and that's going to tell you, is your oil still standing up and preventing oxidation, or are you in a mode where oxidation is able to happen in your oil? Obviously, if your oil can oxidize, that means it's happening inside your machine. That's never a good thing. So when analysis comes in, a lot of times we do have generic slates, but a lot of times most customers end up trying to define a custom slate. So in today's case study that we're going to talk about for IWM, we customized a slate for them specifically that was looking at wear data, contamination data, and physical properties. So, whenever you're working with the customer, if they only have certain parameters that are important to them and not every test is, you want to just cut down the tests, cut down what they're doing, and really focus on what's important to them, helps lower costs down, and then it just makes it more focused, and you're not giving them this giant report and only half of it is really meaningful and has power to them. So just really making sure you get that. And the other one in the lab is timely results. So when you get a sample, you don't want to let the sample sit on your desk for a long time. As it sits there, things can change. So the quicker the sample can get into the lab, and then the faster the lab can analyze the sample, the better it is, because it's going to be most representative of that sample from when you took it. All right, and then making sense of the analytical results. So you've got a report, you're going to work with your customer. A lot of times we try and reach out directly to them and make sure that if they have any questions, we're working with them, talking to them about it, trying to understand what they want to do. They're using that to evaluate the lube health. So in wear, they're looking specifically in lubricants if iron or copper is going up. And a lot of times too with metallurgy, they know that a specific component inside is made from a specific type of metal. And if all of a sudden we see that metal going up, we know that that component is starting to wear. They can open it up, inspect that component and say, yep, I'm seeing some wear on that, and we need to take action. So it just kind of helps catch things and see what's going on. And then also can help evaluate your maintenance practices and implement changes. So say you're testing your grease, and every time it comes back and the grease has consistency is great, antioxidant levels are good, and everything looks okay, then maybe you can decrease your lubrication frequency because your grease isn't getting pushed to the end of life, so you aren't optimizing that life of the grease. You could be saving money and not greasing as often. It's things like that we can kind of work with the customer and try and maximize the potential they're getting from their lubricants. Like I said, the goal is to optimize the performance of the lubricant, whatever it's doing, whether it be draw fluid or fluid that's helping run motors, hydraulic pumps, anything like that. All right, so a little bit of case study. So with IWM, like I said, the lab analysis, We had a custom slate that looks at their viscosity, antioxidants, so specifically the phosphate esters, that's the phosphate and the ester that's added into the oil from the manufacturer, the metal content of the oil, and then the moisture of the oil. So our kind of job as the lab providing feedback is helping with the company making tank management decisions. So if they're seeing that the viscosity is going up really high and that the phosphate and ester levels are dropping, they're going to add some more fresh oil. It's going to increase their levels, decrease their viscosity. So it's kind of us, not a cat and mouse game, but it is a cat and mouse game of just, you see something, you're going to take action to prevent it becoming a problem further down the road. Whenever a customer comes to us, John's come to us before, he wanted to understand viscosities at certain temperatures. So we did a study of his oil and viscosity, and then we were able to give him a chart and say, if you're at this temperature, you're running at roughly this viscosity of your oil. And that way he has an understanding when he goes to then read his temperature and it says that his oil is this temperature, he has an idea of roughly the viscosity that the oil is running through the machines drawing oil, or drawing the wire, sorry. That's on the lab side. And then on the site side, they're using it, like I said, they're using temperature monitoring to monitor, to maximize the wire that they're producing. They have a centrifuge, and I have pictures of some of this stuff afterwards. Centrifuge that they're using to remove the solid metals from their oil, so that's decreasing, helping to maintain the viscosity. They have oil cooler, so that's helping to keep the viscosity or the temperature low and control it. They found in their process that if the temperature got too hot, it could hurt the quality of their product. So by maintaining their temperature, they're maintaining the quality of their product that they're producing for their customers. They also use process and static storage tanks. So instead of just getting rid of the oil when they're done, they actually can take it down in the basement of their facility, put it in a static tank, allow everything that's in it, kind of a sludge for lack of a better word, settle out of it, and then they can reclaim that oil once the sludge has settled out to use in the process again. They also, from our information that we're giving them, like I said, would be adding antioxidants. So if their levels are getting too low, they can increase those. We work actually with the manufacturer of their oil as well, so we kind of have a nice little triangle of conversation going on, working with each other. That way we all understand what's going on. And the results of all this work, I said, has been improved dye life. So by maximizing their lubricant, they're able to control variables that were hurting the dye life previously. So by controlling their lubricant, they've now also extended the life of their dye. So their oil's lasting longer and their dyes are lasting longer by being on top of their maintenance. So obviously that's a cost savings. And then help improve and enhance their maintenance techniques. So, as we've worked with them, they're able to kind of slowly tweak what they're doing and how it's helping in the facility. And some of the pictures on top is the process oil tank. So the oil is getting pumped out of there. You can see the oil tank controls on the left side and the pumps on the right on the bottom. And that's moving it down to the line. These are the oil coolers outside, helping keep the temperature of the oil low. That helps control the viscosity of the fluid as it's being worked through, as the wire is being drawn. So like I said, they have greater control on that temperature. They have a greater control on the product that they're producing. These are the centrifuges that are spinning the sludge out of the oil. So they're able to collect that sludge and then help their oil. And then here's the lines that the oil is feeding. I would like to end by just saying thank you to the Ohio Valley chapter and Dave for inviting me, and for IWM and John for helping me out and participating.
Now, let's review some key points of the video. View WAI's other hardwired videos and subscribe to our channel.